All right, 2.04 was on the area of composite figures. So composite figures just means that you're going to have more than one figure. And so you're going to divide up the figure, find the area of each figure, and then add them together. So sometimes there are more than one way to do this depending on how you want to divide the figure up. So for this first one, it is asking you, and this is actually one from each quiz, an actual quiz question. So this one I would divide up here, just kind of draw you a line so that you have, we have a triangle here, so that's our first figure, and then we have a rectangle. So remember, the area of a triangle is going to be 1/2 the base times the height. Now remember, the height has to be an altitude, which means it's perpendicular to the base. So unless it's a right triangle, it's not going to be a side of your triangle. So this particular triangle, if I let this be my base, since it's a vertical line, I don't have to use the distance formula. I can just count 1, 2, 3, 4, 5, 6 units is my base. And then I'm going to draw in my height. So if I draw in my height, it's perpendicular from the vertex to the base. So if I connect that line, I can see it's 1, 2, 3 units. And so the area of that triangle is 1/2 18, or 9. And now I just need to find my area of my rectangle. Remember, that formula is length times width. And so I can just count, since I've got horizontal and vertical lines. So 1, 2, 3, 4, 5 is my length. And my width is 1, 2, 3, 4, 5, 6. 5 times 6 is 30. 9 plus 30 gives you the answer of 39. That is the answer here. Number 2, you have a little different figure. Now, if you like to work with trapezoids, you could divide this up into 2 trapezoids. Most students seem to like the triangles and the rectangles, so that's the way I'm going to divide this one up. If you did it another way, you should get the same answer. So I'm going to draw a line right here and all the way across, and then I'm going to draw a line right here. So now I've got 4 figures. You can see this is my first figure, my second figure, my third figure, and my fourth figure. So if I take a look at finding the area of this first triangle, base times the height, my base is the red, 1, 2, 3, 4, 5, 6, 7. And then remember, we have to draw in our altitude since this is not a right triangle. So my altitude here is going to be this segment right here, and that is going to be 2 units. So 1/2 7 times 2, it's going to give me 7. Now this triangle is a right triangle, so I can use this segment right here as my height. So my base is 1, 2, 3, 4. My height is 1, 2, 3. And 1/2 4 times 3 is going to give me 6. My third triangle is also a right triangle, and so I can use this segment as my height. Remember, this segment we used earlier, it's 7 units. Right here, that's my height, and 1, 2, 3 units is my base. Multiply that, you get 10.5 for the third triangle. And the fourth figure is my rectangle, and that's my length times my width. And here is 1, 2, 3, 4 times 1, 2, 3, and 12. So now we have each of our areas. You just have to add them all together. So 7 plus 6 plus 10.5 plus 12 gives me a total area of 35.5. All right, this one says the curved part of the figure is a semicircle. So they're telling you we have a semicircle. They want the best approximation of the area. So notice your answer choices. They haven't really found the exact area. They have this plus this. So when we draw in our semicircle here, we draw a line across. You can see that now we have 2 figures. We have a right triangle, and then we have our semicircle. So the area of our triangle is the first area that they have here. So 1/2 the base times the height. And then here you can see that the base is 1, 2, 3, 4. The height is here, so from here to here is 7 units. Multiply that out, you get 14. So now you can at least narrow down your choices, right? It's either got to be this one or this one. And so now we're going to find the area of our semicircle. So remember, the area of a circle is pi r squared. If we're talking about half a circle, then we're just going to take half of that formula. But we have to have our radius. They don't really give us anything here. We've got a sloped line, but this is the diameter. Okay, if this is half the circle, then this has to be our diameter. So we can use the distance formula to find our diameter and then divide that in half to find the radius. So this point is at 3, 2. This point is at -4, -2. And so that's what I've done here, using the distance formula for these 2 points to find that distance. So we've got x2 minus x1, so -4 minus 3 squared plus -2 minus 2 squared. -7 squared is 49. Hopefully you can see that. That's 49. Plus 4 squared is 16. And that's going to give us square root of 65. The square root of 65 is 8.062. And so that is our diameter. So remember, we're going to take half of that. So half of that is going to be 4.031. So that's our radius. And then take half, so square this, divide by 2, and we get 8.25. And notice they left it in terms of pi. And so this is our correct answer. All right, number 4 involved the figure. They told you the figure was a rectangle and a parallelogram, okay, and they want the area. So if we draw in this little segment here, we can see that this first is our parallelogram and this is our rectangle. Remember, the rectangle's got 4 right angles. So the formula for the area of a parallelogram is going to be your base times your height. The only difference with the rectangle is the height has to be perpendicular to the base. So we cannot use this distance as our height. So our length is this distance across, 1, 2, 3, 4, 5, 6. And then we're going to have to draw in the height here. The height is going to be perpendicular to the base. So if we draw this line right here, we can see that's only 1 unit. So that's going to be our height. 6 times 1 is 6. So the area of the parallelogram is 6. Now the area of our rectangle, notice we have sloped lines here. So we have to use our distance formula to find out the distance. Remember, the rectangle opposite sides are congruent, so we just need to find this distance and this distance. So I think this one first. Identify these points. You've got 1, -3, and -2, -4. Plug that into the distance formula, and you get the square root of 9 plus 1, which is the square root of 10. And for now, I just left that as a square root of 10. The length, I did these 2 points here and here. So we've got -1, -3, or I'm sorry, -1, 3, and then 1, -3. And so if I plug that here into my distance formula, I get 1 plus 1 is 2. -3 minus 3 is -6 squared. So 4 plus 36 is the square root of 40. So now we can find the area of our rectangle. The square root of 10 times the square root of 40 is the square root of 400, or 20. And now simply add those two together. We've got 20 plus 6, so our total area is 26. The last one gives you a picture here that's not on a coordinate grid. And so you can see, if we draw in a segment here, that we have a rectangle and a triangle. So our rectangle is simply 5 times 7, right? The length times the width. So 35 units, or inches squared, is going to be our area of the rectangle. And then here is our triangle. It is a right triangle. And so we just need to find the base and the height. So this red is going to be our base. So if the total here is 5 and this is 3, then we know this little section has got to be 2. And then to find our height, we know that from here to here is 7. If the whole is 12, then this has to be 5. And so our formula, 1/2 the base times the height. Our base is 2. Our height is 5. So 10 divided by 2 is 5. Add those two together, and our total area is 40. Hope this helps.